The second part of solving trig equations, the directions tell us to find all the solutions to the equation. So when we write our answers, we'll be writing them slightly differently. Our first example of this kind of problem is a very, very basic one, just to get used to how you write the answers. This one is cosine of theta equals -1. There is only one angle when you are making a single revolution around the unit circle where the cosine is -1. So just like we were doing earlier, we will write argument theta equals, what angle does cosine equal -1? It happens at the angle of pi. The difference here is you want to write a representation for all of the solutions to the equation. So if you were to continue going around the unit circle repeatedly, how long would it take you to get back to pi? It would take a full revolution. If you did just one revolution, that would be plus 2 pi. If you did 2 revolutions, it would be plus 4 pi, and then plus 6 pi. So it's 1 times 2 pi, or 2 times 2 pi, or 3 times 2 pi. So what we do is we say plus 2 pi k. And it doesn't matter what order you write those items in. You just need all 3 of the items. So the 2 pi is saying plus a revolution, and the k represents however many revolutions you want to make. And then the other thing that you include on this is that k, this is the symbolism that you'll see, and this funky looking E thing stands for an element of, and then Z is integers, meaning it has to be 1, 2, 3, -1, -2, -3. It's not a fractional number. On the second example, we've kept it very simple again, just to practice how you write the solutions. So on this one, we want to know what angle or angles will the sine value be the square root of 3 over 2. First of all, it's positive. Sine is positive in quadrant 1 and in quadrant 2. So in quadrant 1, the angle where you get a sine value or y value of square root of 3 over 2 is theta equals pi over 3. In order to get to that again, you have to make a full revolution. So you write plus 2 pi k with k an element of the integers. That takes care of the first quadrant angle. The second quadrant angle would be theta equals 2 pi over 3. Again, in order to get back to 2 pi over 3, you'd have to make a full revolution around. So you write the plus 2 pi k. K is an element of Z. Example C, we have the tangent of theta plus 1 equals 0. So the first thing we have to do is get tangent by itself by subtracting 1. So tangent of theta equals -1. Well, where is tangent negative? Tangent is negative in the second quadrant and the fourth quadrant. And if you think about that, those are diagonal from each other. Keep that in mind. Where does tangent equal 1? We've already talked about that. That's over at the over 4 angles. So the angle that we want here is theta equals, our second quadrant angle is 3 pi over 4. The next place that you would hit that -1 would be at the fourth quadrant angle, which is directly diagonal from it, from 3 pi over 4. And because it's directly diagonal from it, you've gone halfway around the circle, which is pi. So on the tangent function, once you figure out your angle, because the signs are negative in 2 and 4, positive in 1 and 3, you're always going to have those diagonal quadrants where you get the same sign. So instead of saying plus 2 pi k, you just say plus pi k. You only have to go 1 pi until you reach the next angle of the same measure. And then we do the k is an element of z. On example D, we are doing the cotangent of theta minus the square root of 3 equals 0. Again, we have to get the function by itself. So we are going to add the square root of 3 on both sides. And we now have the cotangent of theta equals square root of 3. Cotangent, being the reciprocal of tangent, has the signs in the same places. Cotangent is positive quadrant 1 and quadrant 3. They are diagonal to each other. So in quadrant 1, what angle theta will have a cotangent and x over y of the square root of 3? That happens at pi over 6. And then, because the next place cotangent is positive, is directly diagonal from this, we just write plus pi k, with k an element of the integers. Example E is 4 cosine squared of theta plus 4 cosine of theta equals -1. When you have a squared in a first power of a function, you need to get everything on the same side, make it equal to 0, and factor. So we are going to add 1 on both sides, giving us 4 times cosine squared theta plus 4 cosine theta plus 1 equals 0. If you need to help you see the factoring on this, you can rewrite it as 4x squared plus 4x plus 1. If you need to do that, take the function out and just put an x in to help you see the factoring on it. I have a lot of students who will do that. So this, think about that. What makes 4x squared? 2x and 2x. What makes 1? 1 and 1. And since everything is positive, the whole thing would have to be positive. You can always check yourself by doing the multiplication, doing the FOIL to figure that out. So what that tells me then is that this problem will factor into 2 cosine theta plus 1 times 2 cosine theta plus 1. Well, that's the same thing. There's no need for us to write it down 2 times and solve it. So we're just going to use one of them. 2 cosine theta plus 1 equals 0. First thing we're going to do is subtract the 1. And we get 2 cosine theta equals -1. Divide both sides by 2. We get cosine theta equals -1/2. Where is cosine negative? That's quadrants 2 and 3. So the theta in quadrant 2, where the cosine is -1/2, is 2 pi over 3. In order to get back to quadrant 2, we have to make a full lap around. So we do plus 2 pi k, with k an element of the integers. And then the place in quadrant 3 where cosine is negative 1/2 is 4 pi over 3. When your quadrants are side by side, 2 and 3, 1 and 2, that type of thing, you have to do the plus 2 pi k. And so that's the solution for this problem. Our last example of this type of problem, we have tangent squared of x minus 2 secant of x equals negative 1. Well, notice that we have two different functions, but one's a squared. And if you remember, tangent and secant are in the same Pythagorean identity. So you take the function that's squared and replace it with what it's equal to from the Pythagorean identity. So we are going to replace tangent squared with what it's equal to. That will be secant squared x minus 1. Now continue on writing the rest of the equation. Minus 2 secant x equals negative 1. Remember, we've talked about when you have squared functions, you need to get everything on the same side and equal to 0. So we are going to add 1, which is going to give us secant squared x minus 2 secant of x equals 0. Well, we can factor out a secant here. So we will factor out secant and then take secant squared divided by secant, and that will leave us with secant of x minus take 2 secant of x divided by secant of x. You'll be left with the 2 equals 0. Set each of those pieces equal to 0. So you will have secant of x equals 0 and secant of x minus 2 equals 0. So we've got two things to solve here. Well, when you look at the one on the left, it says secant of x equals 0. Secant cannot be less than 1. So saying the secant of 0 is not possible. So this part of the equation gives you no solution. Going over to the other side, move over the 2 and you will get secant of x equals 2. First, recognize that the value of 2 is okay for secant. It has to be at least 1. 2 is bigger than 1, so we're good. And then remember that if secant is 2, that the cosine has to be 1/2. So where are both secant and cosine positive? That's in quadrants 1 and 4. And then what angles in quadrants 1 and 4 will have a secant of 2 or a cosine of 1/2? In quadrant 1, the angle where that happens is pi over 3. In quadrant 4, that is 5 pi over 3. If you think about it, quadrants 1 and 4 are side by side. Anytime your answers come from side by side quadrants, you have to write plus 2 pi k on each answer. And then on these, k is always an element of the integers.